Okay, there's only one 3-dot problem on the assignment from Chapter 9, so let's get to it. We've got number 8 here from Chapter 9, which is not confusing. We have a uniform soda can, which is filled with a uniform liquid. And they do indicate this is the mass here when full, which is not how I have drawn it, as you can probably tell. But the point is to illustrate, if we want to find the center of mass of the system, then it's going to look, then we're going to need to take the center of mass. It's going to be the weighted average of the two components. It'll look like the mass of the can times the center of mass of the can plus the mass of the soda times the center of mass of the soda. The reason, so in theory you're dealing with solid objects, so you might think I need to do calculus, but you're dealing with highly symmetric objects. So you have a cylindrical symmetry, so you know that radially this is going to be along the center axis. You know that it's symmetric as you spin it, so it has to be, so basically it has to be along the central axis. So the question is basically not a question of x so much as really it's a question of height. It's a question of z. This is more or less the kind of math that you're going to want to put in this. The one thing I do want to bring a point to, so they refer to this point here as h in the problem, I believe. What is the height h of the center of mass of the can and contents? And so in part C they ask what happens to h, which is a very obtuse way of saying, in my opinion, what is getting ahead of myself, h of t, or alternatively, more accurately probably, what is dh dt. Both of those are probably interesting questions to answer. You could answer question C graphically, I think, or by observing a graph if you were to graph h of t. And so now as you're thinking about this, why would h be a function of t? What is a function of t here? Well, all of this stuff about the can does not depend on t. The can's not changing. But this right here, this is the gold mine. This depends on t. So that's the thing to watch out for. Other than that, I think it's a pretty fun problem. My recommendation, and if you don't want to hear it, if you want to truss it out a bit, I don't know why you watch the video, but if you have felt you got it enough and don't want to hear what my recommendation would be, but stop it now. But if you want to hear my recommendation, I would consider a linear rate of exit of soda. Makes life just a little simpler. Have fun.